Texan Global School. Reducible equations. In this class, different processes are analyzed to solve equations that can be reduced or simplified to a quadratic equation. Let us remember that there are three general methods for solving quadratic equations: by factoring, completing the square, and using the quadratic formula. Let's look at a first example. We will solve the following equation. First, analyze the equation to determine the type of algebraic process that will be used to begin its reduction or simplification. One first strategy is to eliminate all the denominators of the algebraic terms. To do this, multiply the entire equation by the least common algebraic multiple of the denominators. In this case, it is x minus 2. By multiplying both sides of the equation by this polynomial, identical factors are cancelled. We can see that all the denominators were eliminated. Now, perform the distributive law of multiplication to develop. By simplifying like terms, we can see that results the quadratic equation for x squared minus 13x plus 3 equals 0. We can solve this first example by factoring. As we saw in previous classes, this first polynomial can be factored using the scissors or cross-multiplication method. There are four possible arrays, in which only the last allows obtaining the linear term by multiplying in the direction of the scissors. So, the factors of this trinomial are 4x minus 1 times x minus 3. Set each factor equal to 0. And isolate the variable. Resulting two solutions, x equals 1/4 and x equals 3. We can verify these results by substituting them, separately, into the original equation. By performing the operations, we can see that both cases are correct because the equality is satisfied. This same example can be solved by another process. We can perform the operations on fractions, as seen in the previous class on rational algebraic expressions. So first obtain the least common algebraic multiple of the denominators, which is x minus 2. Now, the same algorithm is used to add or subtract fractions. The least common multiple over the first denominator times the numerator, and the least common multiple over the second denominator times the numerator. Develop the numerator. Now, send the denominator to the other side of the equation, which passes multiplying, because of the multiplicative property of identities. By simplifying, we can see that results the same quadratic equation, for x squared minus 13x plus 3 equals 0. When factoring, setting each factor equal to 0, and solving, results the same two solutions, x equals to 1/4, and x equals 3. So, they can use any method to solve these types of equations, canceling denominators, or performing algebraic fractions. In both cases, the least common multiple of the algebraic expressions has to be obtained. In this other example, solve the following equation. We will eliminate denominators by multiplying both sides of the equality by the least common algebraic multiple. In this case, it is x minus 1 times x plus 2. When performing the products, we see that the denominators are eliminated. Develop and simplify, hence results a quadratic equation, which we will now solve by completing the perfect square trinomial. To review, since the numerical coefficient of the quadratic term is not 1, multiply both members of the equation by the multiplicative inverse of the numerical coefficient of the quadratic term, to make it 1. So, multiply the entire equation by negative 1/3. Now, send the independent term to the other side of the equation. Then, multiply the numerical coefficient of the linear term by 1/2, and square the result. In this case, results 1/4. Hence, add this value on both sides of the equality so as not to alter the equation. Thus, we complete the perfect square trinomial. which, when factored, results a square of a binomial, remembering special products. To factor these types of specific cases, we can obtain the square root of the quadratic term and the independent term. Thus, substitute to find the square of a binomial. Results, x minus 1/2 squared equals to 9/4. Finally, isolate the variable, obtaining two results. X equals 2 and x equals -1. Likewise, we can verify each result independently by substituting it into the original equation. We can see that both cases satisfy the equality. We will solve this last example by performing the algebraic fractions. In any case, we must factor the denominators first. The least common multiple of the algebraic expressions is x plus 2 times x minus 1 times x plus 1. Now, use the same algorithm to add or subtract fractions. The least common multiple over the denominator times the numerator, and the process is repeated for each term. Now, develop the products of the numerator. And with the multiplicative property of equalities, send the denominator to the other side of the equation, multiplying. Then, by expanding and simplifying, results a quadratic equation that will be solved using the quadratic formula. First, identify the values of a, b, and c. Then, substitute them into the formula and develop arithmetically. We obtain two results, when x is equal to 2, and x equals to -3. Likewise, we can verify each result independently by substituting it into the original equation. We can see that both cases satisfy the equality. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com